Hello students, I am Dr. Gajendra Purohit. I upload videos for engineering mathematics B.Sc on my YouTube channel. If you are preparing for any competitive exam where higher mathematics is asked, then my channel can be very helpful. And through this I tab here, you can check out my videos. Let me tell you that today I will be explaining you about first order and higher degree differential equations in this video. And I have uploaded a video on this topic where I have explained how to solve questions using the solvable for P method. You can check it out through I tab or through the link in description. Let me tell you that this concept is very easy. You just need to understand it a little bit. When first order and higher degree differential equation is given, students are confused whether it is solvable for P or is it solvable for X, solvable for Y, or is it in Laurent form. I'll explain it gradually. And today we will see that if we have any first order or higher degree differential equation given, then how do we know if it is solvable for X and what is the procedure to solve it? Suppose a differential equation is given where it is of this type, and if the function is coming here in form of x is equal to y and p, then we can solve it for x. It means it will be solvable for x. You just have to differentiate x with respect to y. We know that dy by dx is p, so dx by dy will be 1 upon p. Then we will factorize it here and we will calculate the value of p and put value of p in this equation, which will give us the answer. Now let me try to explain this with an example. For example, this question is given. Now you would ask, how can we know if this is solvable for x or y? Because x is appearing once and y is appearing twice. And since x is appearing once, so we can write x is equal to y and p, right in this form. Therefore, this will be solvable for x. Let's see how will we solve it. Look here, students, I will write this like 2px is equal to y minus y square into p cube. Now we will simplify this as x is equal to y upon 2p. Minus this will be y square p cube, upon it will be 2p in denominator. When you will simplify this, then it will become x equals 1 upon, it will be y upon 2p in the denominator minus this will be y square p square upon 2. Now this will be differentiated with respect to y here. Let's differentiate with respect to y. When we will differentiate, we will get dx by dy. Now as you can see, it is y here, and this p is a function of x and y, so it will also be differentiated since it's a derivative. Now first of all we will differentiate y, we will get 1 divided by 2p. Then differentiate y with respect to y, right students? Here we will leave y and differentiate p. So here 1 upon p will become minus 1 upon 2p square and p will become dp by dy. And now we will differentiate it with respect to y. We are doing it again with respect to y. So first we will differentiate it. We will get this as 2y p square upon 2. Then we will keep y square and differentiate this. So 2p upon 2 into dp by dy, right? We will get this value here. And now we know that we can write dx by dy as 1 upon p. So it will be 1 upon p is equal to 1 upon 2p. Here minus sign will come. This will be y upon 2p square into dp by dy. And this 2 will get cancelled with 2 here. This will be minus yp square. Here also 2 cancels with the 2. So we have minus y square p into dp by dy, right? We can take this term to the other side and then this 1 upon p will become minus 1 by p on this side. Now we will simplify it. And here 1 upon 2p will be left. What we will do? We will take all these terms on this side. I will change the color a little bit so that you can understand more clearly. 1 upon 2p will come on this side. So here we will be left with 1 upon 2p. Then all these 3 negative terms will become positive on this side. So first I will take yp square. And then I will take both these dp by dy terms to the other side. When we will take this term to the other side, we will get y upon 2p square, dp by dy, and here this term will be added y square into p. dp divided by dy is equal to 0, right? What we will do here, this term will be as it is, 1 upon 2p plus yp square. And now what we will do here, we can take out something common here, right? I will do one thing, I will take out y divided by p common here. And we have dp by dy also common here. So we will take dp by dy common on the end of the expression, right? We will get 1 upon 2p here plus. We have taken y common and 1 upon p common. Since we have taken p common, it will become yp square here. Are you getting my point? And I have taken out this term dp by dy as common in the end here. You can notice these are similar terms. This will be 1 upon 2p. Plus yp square will be there. And when we take this as common, then 1 will be left here. And this will be y by p into dp by dy is equals to 0. So either this will be equal to 0 or this will be equal to 0. Now you have to set the derivative factor equals to 0. Why we will not keep this equal to 0? Because then we will get the value of p, but the constant will not come. We will put both of them to 0 and calculate the value of p. Then we will put that value of p here. Whatever solution we get, it should have at least one constant term in it because it is first order and higher degree. So we must get at least one constant. If you put this here, we will not get a constant, so we will neglect it. And we will put this term instead. It will be 1 plus y by p into dp by dy is equal to 0. Now what we will do, we can separate them, so dp by dy. But first of all, I will take it on that side. Then this will be y by p into dp by dy is equal to minus 1. When we will separate it, let me write it here. We will get dp by p is equal to the negative of dy by y. And when we will integrate it, on this side take it as log c. When we will do its integration, we will get log of p is equal to minus log of y. Plus log c, this minus y it will go below, then log p will be equal to log c divided by y. And log will get cancelled with log. So the value of p will become c by y here, right? You have to take this value of p and put it here in the question. Let me use a different color here. As soon as we will substitute the value, the answer will be y is equal to the value of p, which we are getting as c by yx, plus this y square will come as it is. And here the value of p cube will be c by y whole cube. When we will simplify this, then the answer at this point will be 2 into cx divided by y. Y cube and y square will get cancelled, which will give y. It will become c cube upon y. So we will get the answer. If we will take y to this side, we will get the answer, which is y square is equal to 2cx plus c cube. This is the correct answer. In this way, we solve this type of question here. Is it clear? Now let's look at this question. Here also x is given once. Now what we will do, we will take this term and I will write this like 4xyp is equal to p cube plus 8y square. Here you can keep x as it is on the same side. We will keep x on this side and divide 4yp on the other side. This will become x is equal to p cube upon 4yp plus 8y square divided by 4yp. And now on cancelling out the p, we will get x is equal to, it will become p square upon 4y in the denominator. This y square will get divided by y, and with 4, so this will become 2y upon p, as y in the denominator will get cancelled. Now students, we will differentiate it with respect to y. Is it clear? Now what we will do, we will differentiate the terms with respect to y, right? And when we will differentiate with respect to y, then at this point we will get this dx divided by dy. Now here, first of all, we will differentiate p square. Then we will get is equal to 2p divided by 4y on this side, right? And here it will be multiplied by dp by dy. Is it clear? We will leave p square and differentiate this. Then for 1 by y square, it will be minus 4y. So I have put minus. Similarly, when we will differentiate it with respect to y here, then we will get plus 2 upon p. Now we have left y and differentiating 1 upon p with respect to y. It will be minus 1 upon p square, and this is dp by dy, right? Now you can notice that here we will get the value of dx by dy as 1 by p. 1 by p is equal to, this will be cancelled with 2, so we will get this as p divided by 2y multiplied by dp by dy, and here it will be minus p square upon 4y square, and plus we will get 2 upon p, and here minus 2y divided by p square into dp by dy. I hope you are getting it. We will take 1 by p to the other side. So if we take it to the other side, then 1 by 2p minus 1 by p will give 1 by p. Minus, and here we will take this term together, that is p square upon 4y square, right? And now I will take both of these terms together. And these terms are p divided by 2y multiplied by dp by dy minus 2y divided by p square multiplied by dp by dy is equal to 0. So I have to make the same factors here, right? Now in that case, what should I do so that we obtain the same factors here? Now I need p here and I do not need 2y in numerator, because if we consider this, then I will take 2y divided by p common. When we take 2y upon p common, then we will get 1 upon p here, right? And minus, this will be p square divided by 4y square. Now what we will do here, we will take minus p, sorry, not minus p. We will take 2y upon p common, and we will also take dp by dy common. Now you can notice 2y upon p is taken out, and we have also taken minus sign. So this will be 1 upon p. And you will notice that when you take 2y upon p and here it is p upon 2y, then its square will come. So it will be p square divided by 4y square. Now when you will again multiply it, this will again become p upon 2y. This will be equal to 0. You can notice that this will become 1 upon p minus p square, and it will be 4y square in denominator. When we will take this out common, then this term will be 2y upon p into dp by dy equals to 0. Either this will be 0 or it will be 0, but we will not keep this 0. We will put the derivative 1 equal to 0. And when we will put this equal to 0, it will be 1 minus 2 upon yp dp by dy is equal to 0. When we take it to the other side, then we will get 2y divided by p. It will be into dp by dy is equal to 1, which implies this will become dp divided by p is equal to dy divided by 2y. Let's do one thing, leave the 2 on this side. Let me erase this 2 from here, and then I will keep 2 here, and this is dy upon y, and I will do its integration here. This is plus log c. And now we can notice that on simplifying, this will become 2 log p is equal to log y plus log c here, right? On further solving, we will get p square is equal to yc. We have to find the value of p here. What is the value of p? It will be square root of y into c. Now we will substitute the value square root of yc in place of p. It is p cube here, so it will become yc to the power 3 by 2. Then this will be minus 4xy, and here this term will be multiplied by the square root of yc. Is it clear? Plus 8y square is equal to 0. So we will get this value, which will be the answer of this question here. In this way, it can be solved very easily. I hope you have understood solvable for x, and this question is for the comment box. Try solving this question using the same method and tell me what will be the answer of this question in the comments. Clear? Let me tell you the 2.0 series of the differential equation, or you can say the upgraded videos that I am uploading. You can check out from here. And you can check out my old playlist from here, where I have uploaded differential equation videos. You can subscribe to my new channel from the link where I upload many short tricks and tips for GATE, IIT-JAM, CSIR net exams, and you can also follow me on Instagram. Thank you so much for watching. Do like, share and subscribe to the channel. Don't forget to answer this question in the comment box.